Prove the following identity. Looking at this, it looks like there's stuff to work with left-hand side and right-hand side. For sure the right-hand side. I'm actually going to start with the right-hand side, and then we'll see if we want to move to the left-hand side or not. So cos 2x, I have options. I can either use the one with both, either or. I'm going to choose the one with just cosine. Since I see cosine in here, it seems like maybe a good pick. So I'm going to replace cos 2x with 2 cos squared x minus 1. Then I have minus cos x. Sine 2x, I only have one formula to choose from, so that's nice. You know what to pick. So 2 sine x cos x plus sine x. Okay, now looking here, this isn't not necessarily in an order I'm used to. Nothing cancels, nothing combines, but I'm going to write it in descending order. So it's 2 cos squared x minus cos x minus 1, because now I'll be able to factor it. On here, I can factor out a sine x. So let's do that. So sine x. So I have 2 cos x plus 1 on that there. Okay, so let's have a look at factoring the numerator now. So 2 cos squared x, you know that this has got to be 2 cos x cos x. One sign's positive, one's negative. I don't know which one yet, but I know that the only factors of 1 are 1 and 1. So that this, when I'm combining this, I need a positive cos x, 2 cos x. I need the 2 cos x to be negative, so this must be a minus sign. This must be a plus. We'll write our denominator down here again. These are identical now, so they cancel. So we get cos x minus 1 over sine x. Now, I could keep going on this side, but I would find it easier probably to go the left-hand side. So I'm going to show you how I would do that over here. So I'm going to simplify this. Cotan x is equal to cos x over sine x minus cosecant x is 1 over sine x. So this is equal to cos x minus 1 over sine x. And now I have this equal to my right-hand side and this equal to my left-hand side. So that's the easiest way to go about this one. It's worth mentioning. Let's say you did continue down this side. How would you get to cotan x? You can separate these. We're so used to combining on one and adding and subtracting, but I can put these over each individual denominator. So if you think about this, I can separate this. If you were to subtract this, you would get a common denominator when it'd look like this. So I've just sort of undone the subtraction, and then cos x over sine x would equal cotan x, and 1 over sine x would equal cosecant x. So that's an option as well if you did continue one side, but you can certainly work both sides. The last little statement here that's important to notice, note verifying, which we were doing earlier. An identity using a specific value indicates that it's true for only that value. So when we are substituting specific angles, so for example, if I substituted x equals pi by 6 in here and evaluated with the numbers, that proves it's true just for that value. When we prove it like we've been doing here in this question, that proves it's, so proving an identity is done algebraically with your formulas, and it validates the identity is true for all permissible values of the variable.